In this tutorial, we're going to be using AI to create an enemy that can chase you around a level, and importantly, around obstacles. This is so much better than someone who chases you right into a wall. And this is fine. We're going to fix it. You can click the link in the description, and it'll take you to this game with the map, player, cool gun. So, you can make your own version by clicking the remix button there, and we can get into this game. So the first thing we'll need to create is some way for the enemy to find their way around the level to reach the player. And that is going to look something like this. You can see there are these little blue dots on the tiles of the map. These are like breadcrumbs that the enemy is going to be able to use to find their way to the player, especially around obstacles. So I'm going to tell Rosie to create a math mesh for our game's map. That means we'll place a point at the middle of every tile in the map, and we'll want to be able to see these, make sure I have them in the right spots. So I'll say visualize the points as big green dots on the floor. Might be a little hard for you to see, but there they are. There's these little green dots, and they're at the center of every tile. Alright, so now that we have some points on the level that the enemy can use to move around, we need a way for the enemy to say, which ones should I follow to find my way to the player? And that will look something like this. You can see there's a red line being drawn from the enemy to the player about every second. And it's the shortest path to get to the player. Now, let's go back here and tell Rosie to use the A-star algorithm to create a path to the player from the enemy. Now, you don't need to know how A-star algorithm works. Rose is going to handle all that. Just trust it will find the shortest path to the player. So, from there we could say, we want to see it, right? So I'll say visualize the path as a red line between the points on the map. And another thing would be, when should we create this path? If we create it just at the start of the game, yeah, we'll find the shortest way to the player. But what if that's why it would be great to tell Rosie to create this path every second in the game, so it's always up to date. The last thing I'll say is, don't use the path to move the enemy just yet. And that way, we can just make sure it works first. There's the path. If I go here, you see it's updating. So if I go around, he'll come back around. It's great. Alright. So now that the enemy knows how to find the player, all that we have to do now is to make the enemy follow the path to reach the player. One thing we might want to think about is, how is our enemy going to move on this path? I'm going to say the enemy should move smoothly and consistently, no starting or stopping, from one point to the next along the path. Alright, so what you should see is the enemy is now following that red line to find the shortest path to the player through these little breadcrumbs in our level. There's a couple of issues we can sort out in a bit, but first, did you get a broken apply button too? I sure did. The reason for that was in the code that Rosie created, there is a comment, this gray block, this line. Rosie left out some of the code that was already in our game when writing new code, which then made it impossible for Rosebud to automatically copy and paste this new code, and the apply button broke because of that. That's perfectly fine. What I did instead was I hit retry, and I went to the top, and I wrote this message at the end. Write complete edit blocks, which means do not comment out any existing code. Then, when Rosie wrote the new code, it was complete. It worked. So I suggest you try the same. So one issue you can see really easily is that path is so outdated. That's because we're updating it only every second. So I can just say, make the enemy find a new path to the player every quarter second in the game. Alright, so the movement is so much more smooth. This is amazing. Look at that, and he can even, like, cut me off. Now that our enemy is moving very smoothly, you can notice the biggest problem is that he just moves like a robot from tile to tile. So, why is that happening? Frankly, I don't really know. You should be able to go diagonally. So, what I'll do is ask Greasy how to fix it. Like, our enemy is only finding paths that lead them to move up, down, left, and right. Why? What changes are needed so the enemy will move diagonally as well? That's a diagonal for sure. He's finding his way so much better now. So the last thing I'd like to show you is how we can clean up our game so that the visuals we've been using to see how pathfinding is working don't distract you or the player. We could say hide the visualization for the path and the navigation map. If you want to bring it back later when you're developing the game, so if for like debugging or whatever, you can tell Rosie to use a control variable so that we can easily turn the visualizations back on later. A control variable will simply be a switch in the code that you can tell Rosie to flip on or off to bring back that feature without having to rewrite all the code. So now you can run the game and you'll see the visuals look a lot cleaner, which is awesome. So this is what our project should look like by the end. If you followed along on Rosebud and had a ton of fun, then I'm sure you have some great ideas for how to use this for your games. If you want to see some more tutorials on 3D game dev, then please leave a comment in the comments, and I'll see you later.